We're going to factor a quadratic function, f of x, and this problem, the way it's designed, it walks us through a couple of those steps that we're going to have to take in this process. And the very first thing, if you notice, the first thing it says we're going to do is check for a GCF. I find that always makes things much simpler. If you don't find a GCF, it's not like you wasted a whole lot of time, but if you do find one, you just made this a lot easier. So you see these numbers are a little bit intimidating right here, but I recognize pretty quick that I can factor out a 4 from this. I'm going to pull out a factor of 4, and look what's left behind. 6w squared minus 5w minus 25. Okay, now when you take out a GCF, you're still left with the trinomial. We're still going to have to factor that, but I'm just going to take that 4, I'm going to put it over here, and I get to forget about it. I get to just deal with what's on the inside of these parentheses. So from this step forward, everything that I'm talking about in this problem is just using that smaller trinomial, the one with the smaller coefficients. So let's work on that. So the factor, the GCF here is 4. And then moving forward, I'm going to start using the big X process that we've talked about in class. I multiply the quadratic coefficient and the constant together, and that gives me, let's see, negative 150. That's 6 times negative 25. The middle term is negative 5. So that drops down here. And now I need two numbers that multiply to negative 150, but they add to negative 5. Now, if you're like me, you're not too good at guessing this part. You might want to make a table over here. So here's what they have to multiply to. Here's what they have to add to. And I'm just going to start guessing. I know that 150 is divisible by 5. So I'm going to say, okay, well, 5, and let's see, the other number, that's going to have to be like negative 30. Okay, but if I add those up, I get negative 25. So I'm kind of a good distance off here. Let's try another one. Let's try 6. And I've got a calculator, so I know that 6 goes into 150 25 times. But I see when I add those up, still pretty far off. It's like 21. So I try 7, I try 8, I try 9. 150 is not divisible by these things. Eventually I get to 10. And I like to go in order so I don't miss anything. 150 divided by 10 is negative 15. And hey, there we go. We got it. So this is our set of special numbers. And I skipped a few steps here, so let's fill this in. It has to multiply to negative 150. It has to add to negative 5. Okay, and those two special numbers that we just found were negative 15 and 10. Now, a lot of people recognize this factoring technique so far, whether you organize it by a box or by grouping or whatever. But here's why I like this particular method that I often show in class. Look what I'm going to do here. This might seem kind of like magic. I don't have time to explain why it works now. That would be another video. But I'm going to divide each of these special numbers I just found by whatever the quadratic coefficient was. So I'm going to divide it by 6 on both of these. It might seem kind of spooky the first time you see it. Now look what happens. I'm going to write my answers down here. Okay, so I've got x minus 15 over 6 times x plus 10 over 6. Now that's not the right answer. We have to simplify these. And this one simplifies to, let's see, that's 5 over 2. This one simplifies to 5 over 3. Yeah, did that right. This is still not the right answer. There's one more little step. We're going to have to, now, for reasons I, again, don't have time to explain, we're going to take these denominators that are left after you tried to simplify, but maybe you couldn't go all the way. If you have any denominator left there, sometimes you will, sometimes you won't, but if you have a denominator left, you move it out in front of the x. So we get 2x minus 5 and 3x plus 5, and that is the factored form. This is your actual answer. So I can take that over here, put that in my answer box, 2x minus 5. Don't forget, you still have that GCF we found earlier. That's out front. Okay, so this was a fairly complicated factoring problem. We can solve it pretty quickly using this method. You might have a problem that's simpler than this. You might have one with no GCF at all. Or maybe one of these numbers simplified so you didn't have to swoop that denominator over. That's fine. There's all sorts. This technique works for any quadratic which can be factored.